Here we are with Unit 7, Lesson 8, Combining Bases. Today we're going to talk about same exponents, but a different base. So we're going to incorporate thoughts from our previous lessons talking about the exponent rules, but today we're going to see just a little bit of a different approach to it that evaluates values using exponents. So first thing when we look at same exponent, different base, we want to look at this first thing that says evaluate 5 to the third times 2 to the third power. When we see this, we remember that 5 to the third power is 5 times 5 times 5. And then we're multiplying that by 2 to the third power, 2 times 2 times 2. When we go and extend that value in here, remember that evaluate means simplify it to its simplest terms, meaning no exponents. 5 to the third power is 125. 2 to the third power is 8. And when I multiply 125 times 8, I get 1,000. When we evaluate 10 to the third power, remember that 10 to the third power is 10 times 10 times 10, which we know is 10 times 10 is 100. 100 times 10 is also 1,000. And so what we see with this is that 5 to the third power times 2 to the third power is equal to 10 to the third power. And so the question is, how does this work? When you consider the fact that the exponents are the exact same values, we can turn this into something that would look more like a distributive property, actually more like a power of a power thing, or what we call a power of a product. The product would be 5 and 2, and we would take the power of that product to give us the value of 10 raised to the third power. And as you can see, the 10 comes from the 5 times 2. We know that since both of them are being raised to the same power, we can group them into the same grouping and suggest that the 5 and the 2 are both raised to the third power, simplifying our values of 5 and 2 being multiplied together to be 10. And then we see 10 to the third power. This would be an example, again, of what we call a power of a product. So again, power of a product inside. But there's a more specific rule that goes with this. The name of this rule is called the exponent product rule. The exponent product rule states that for any value raised to a power being multiplied by any value raised to the same power can be interpreted as each of those bases being multiplied together and being raised to the same power. So because both factors have exactly n factors, or because both sides, both expressions have exactly n factors that are a and n factors are b, or excuse me, a to the n and b to the n, we see that those values are there. More generally, this is always for positive numbers that we'll see this. Okay. The next piece of the lesson goes into this one to explore the exponent product rule. Don't forget that name because you will see that on your assessment. In the exponent product rule, we see 5 to the third times 2 to the third is more expressly written, just like I just showed it a moment ago. And we see with these other values the same type of situation. 3 to the second power, 3 times 3 times 7 times 7, which is ultimately equal to 3 times 7 times 3 times 7, just 2 times, or simply 21 times 21. And where we get that next step with that is 21 to the second power. We can do the same thing here with 2 to the fourth times 3 to the fourth. And that will give us a value of 2 times 3 once, twice, 3 times, 4 times, which ultimately equals 6 times 6 times 6 times 6. So we get 6 to the fourth power. Now, how could we get 15 to the third power? The simplest way to think about this is to factor out 15. And we can be thinking, well, that's going to be 3 times 5 is 15. And I need to have that product 3 times. And then the step before that would just simply be something like 5 times 5 times 5 times 3 times 3 times 3. And then we see going backwards into these pieces that we have 3 to the third power times 5 to the third power. Okay. 30 to the fourth power has a couple different ways we can think about this. My first thought with 30 to the fourth power is 5 and 6. So I could be thinking about 5 times 6, 4 times. And that would give me 30 to the fourth power. I also think about 2 and 15. You could even do 1 and 30. There are plenty of options for this, but either way, what we see with this is we simply end up with 5 times itself 4 times, being multiplied by 6 times itself 4 times, 2 to the fourth times 15 to the fourth. What you'll notice and you'll recognize with this is that the product of the two bases will result in the base of the final exponent as long as the exponents are exactly the same. So when we go on, we continue with this 2 to the fourth. Hopefully by now you're catching on. This is 2 times 2 times 2 times x times x times x times x. And then we simply see that that's 2 times x 4 times, which means that we can't really separate out much more with this, but we do need to say 2 times x raised to the fourth power. But hold up. If you do not include parentheses on this one, you will be wrong, because without parentheses, that would simply state x to the fourth power, like this, and it would not raise that fourth power to the 2. So we have to include that parenthesis there. So again, the same type of thing will be here with a to the n times b to the n. That would be any number of a's being multiplied together times any number of b's being multiplied together. So we would simply see with this one, a times b n number of times. We cannot forget to put those parentheses or else it will not affect everything correctly. With this next one, I could sit there and work up all the way through and write every one of these out. I'm just going to simply write it like this. Just the 4 of them. And what we see with this is we can get into a simpler shot with this and see 7 times 2 times 5. 2 times 5 is 10, times 7 is 70, and we see 70 to the fourth power. So then we have to ask that question. What happens if neither the exponents nor the bases are the same? Can you write 2 to the third power times 3 to the fourth power with a single exponent? Well, we have to think a little bit deeper with this one and consider what are the values. The bases are not the same, so I can't add the exponents. The exponents are not the same, so I can't multiply the bases. So what if I look at this and I see 8 times 3 times 3 to the fourth power is 81. Maybe I can think about this as 2 times 2 times 2 times 3 times 3 times 3 times 3. What you'll notice with this is all just multiplication straight out across. So what if we just cut it off here where we recognize this is 2 times 3. We have that grouping, that grouping, that grouping, and then we have this last lonely 3 out here all by itself. We can write this as not a single exponent, but we can say 2 to the third times 2 to the third. This would be 6 to the third times 3. And then the question would have to come down to or beg, can I get that into a simpler form? Can I simplify 8 and 81 and make that into a single exponent value? There may be a possibility. We're not going to get deep into that right now, but do understand with this is that a single exponent, this one, just because it has an exponent does not mean this expression is a single exponent expression. We still have a 1 here. So without the bases being the same, without the exponents being the same, we don't have much hope yet for being able to break this down into single exponent form. How many ways can you make 3,600? It says that I would give you your group tools for this to visually display in these 3 columns. And this would be a game that you can go ahead and play if you desire. Go ahead and look through it and try and give this a start. But the problem is you won't have any of the tools to be able to do it. So What I'm going to do is just quickly, instead of doing that, I will remind you of a couple of things. These values right here are things that you need to absolutely know. You need to know this one is called the product of powers. This one is quotient of powers. And the final one, as we learned today, has a special name. It's called the exponent product rule. Okay, so those are the main things. Are you ready for more? You've probably noticed that when you square an odd number, you get another odd number. And when you square an even number, you get another even number. Here's a way to expand the concept of odd and even numbers for the numbers, or for, concept of odd and even for the number 3. Every integer is either divisible by 3, one more than a multiple of 3, or one less than a multiple of 3. Go ahead and play with this a little bit. For example, we would see one more, one less is 3 and 4, 7 and 25. Or one more than multiples of 3 are 4, 7, and 25. So one more than multiples of 3, one more than 3 is 4, one more than 6 is 7, one more than 24 is 25. You have 3 more examples. We can continue to see those. One less will be these values here. Question comes down, do you think it's true when you square a number that it is, or that is a multiple of 3, your answer will still be a multiple of 3? How about for the other two categories? Try squaring some numbers to check your guesses. Go ahead and give it a shot just as an extra piece, extend your learning, and I want to see what you come up with. In summary, before this lesson, we made rules for multiplying and dividing expressions with exponents that only work. There was the key thing. Before this, we were working on things that only worked when the expressions have the same base. For example, 10 to the third times 10 to the second equals 10 to the fifth. This was an example of product of powers. And then 2 to the sixth divided by 2 to the second was equal to 2 to the fourth. This was an example of quotient of powers. In this lesson, we studied how to combine expressions with the same exponent but different bases. For example, we can see that 2 to the third power times 5 to the third power can be expanded out into each of their individual forms and then regrouped to 2 times 5 and 2 times 5 3 different times. And we see that grouping still extends to 10 to the third power. We noticed in the previous example that the 2 and the 5, they could be replaced with any numbers or any variables, and we would follow that rule, and that's how we derive this rule right here for the exponent product rule. All right. That is it for our lesson today. Thanks for checking in. Please remember to show your work, do your best. When you get into the homework, do your best on the homework to give your best responses. Don't forget to reach out if you have any questions or if you get stuck on anything. Happy to help. Have a great day.